Hello, my dear students of secondary 1. Today we'll speak about thermochemistry. Thermochemistry is a great science. So, this thermochemistry, from its word, thermo and chemistry. Chemistry refers to the reaction. Thermo means heat or energy. So, the science which is represent the change of energy inside the reactants or the products is called thermochemistry. So thermochemistry is a branch of thermodynamics. Thermo here in both of them refers to the heat, and dynamic it is against the word static. Static means stay in its place. Dynamic means move from one place to another. So thermodynamics means thermal energy move from one position to another. Thermo means heat or means energy. Dynamics means moving. So the science which interested in the studying of moving of energy from one position to another is called thermodynamic. Thermochemistry is the science which is interested in the chemical and physical changes in energy during the chemical change or reaction or during the physical change. Physical change or chemical change accompanied by a change in energy of the reactants or the products, or a change in energy while some physical processes happen. So this change in energy is the concern of thermochemistry. So what is energy at the first? We need to have a physical performance. We need some energy. So the energy here refers to the needed energy that we want to acquire, and also if we want some mental activity, this mental activity requires also an energy. So energy is very important in our lives, but energy takes different forms. Energy in the nature cannot be created nor destroyed, like the matter of the substance. The substance cannot be destroyed nor created. And also energy, it has also a preservation law which refers to that the energy in the whole universe cannot be created nor destroyed, but it transforms from one form of energy to another form. So what is the forms of energy which can be obtained here? What is the forms of energy in the universe? Here is chemical energy, heat energy, electrical energy, light energy, kinetic energy, nuclear energy. A lot of things are forms of energies. Energies in isolated system inside it cannot be increased nor decreased. Now the universe, if you look at the whole nature or the universe, is an isolated system. This isolated system contains a very constant energy. It cannot be created. We cannot create an added energy to it. We cannot destroy an energy which exists in this universe. And in the same time, energy has different forms, so it can transfer from one form to another form. Okay, so the energy transforms from heat energy to electric energy, from chemical energy to electric energy, from chemical energy to light energy, from light energy to chemical energy, kinetic energy to heat energy. So it can transform from one form of the energy to another form. Here we'll speak about the law of conservation of energy. The law of conservation of energy. The law of conservation of energy here, as I have discussed from some minutes before, it is that the energy cannot be destroyed nor created, but it can be transformed from one form to another form. Okay, so this is the law of conservation of energy, which states that in any physical or chemical change, Energy cannot be created nor destroyed, but it is transformed from one form to another. So, thermochemistry here is the science which is concerned with the change in heat or the change in energy while chemical process happen or physical change happen. Physical change, chemical change, accompanied by a change in energy of the reactants or the products. So this accompanying energy is the main concern of the thermochemistry. And thermochemistry is a branch of a great science which is called thermodynamics. Thermodynamics means the transference of energy, which is dynamics, the transference of energy, thermo, from one position to another, which is the word dynamics. So we have to know four main basics of the thermodynamics before going into the details of thermodynamics. There are four main things, four large large subjects we have to study. These subjects are the system and surrounding. First law of thermodynamics: heat and temperature and specific heat. So let's speak about the system and the surrounding. So the system and the surrounding, when we do a chemical reaction, this chemical reaction is in a container. What is inside the container? We called it a system. Around the system there is the surrounding. The surrounding outside, the system inside the container. The walls of the container we call the boundary. So system inside the container of the chemical reaction, or in the container in which the physical change happen. Around the container outside there is a surrounding, and between the surrounding and the system there is the system boundary. Okay, so we have here the system boundary and the surrounding. The system is the reactants and the product or the reaction medium. The system boundary, the wall of the container, may be a flask or a test tube. The surrounding means the medium surrounding the reaction container, like the laboratory. What is the importance of the knowing of system and surrounding in the thermochemistry? Look, there is a transference, or there is moving of energy from the system to the surrounding, and from the surrounding to the system. So if the system loses energy to the surrounding, the total heat or the total energy of the system decrease, and the total energy of the surrounding increase. In this case, before any transferring of energy, the temperature of the surrounding is lower than the temperature of the system. The temperature of the system is very high or high in comparison with the temperature of the surrounding. So the energy moves from the high temperature to the low temperature. So if the opposite process happen, energy transfers from the system, from the surrounding to the system. In this case, before transferring, the temperature of the surrounding is higher and the temperature of the system is very low. So in this case, the energy moves from the outside or the surrounding to the system. Okay, so we'll speak in details about this. So here is the system. Here is the system, what is inside the container, which the physical change happen or the chemical reaction happen. And outside here there is a surrounding. Surrounding here refers to the outer area around the system. So in the first case, in some reactions or some physical changes, energy goes from the system to the surrounding, as here, to the surrounding. So In this case, before transferring of energy from the system to the surrounding, the temperature of the system at first is high and the temperature of the surrounding is low. So a transference of energy from the high temperature to the low temperature. It may be that the system temperature is low and the temperature of the surrounding is high. So the energy moves from the surrounding to the system. So there is a transference from the system to the surrounding in some cases of energy, and there is a transference of energy from the surrounding to the system. If the energy moves from the system to the surrounding, so the total energy of the system decreases as some part of the energy of the system goes out from the system. And if the energy goes from the outside or from the surrounding to the system, inside the system, it means that the energy of the system increases as it accepts an excess energy from the surrounding. And in this case, the energy of the surrounding decreases. So we have also to study the types of system. Types of system. If we do an experiment in an open test tube, if we do an experiment in a closed test tube, if we do an experiment in an isolated test tube, there is a difference, a great difference between these three kinds. Open test tube, if we heat what is inside the test tube, it may be evaporated, so the system loses some matter from its substance to the outside, and also it is heated, so the system accepts or acquires energy from the outside. In this case, we call this system an open system. Open system, like this system here, is the system which allows the transfer or the exchange of matter and energy between the system and the surrounding. Here, this is open system. Open system, it is the system that allows the transference or the exchange between the system and the surrounding in concern in matter and energy. So if the system and the surrounding exchange energy and matter freely, then we call this system an open system. So an open system refers to the system which allows the transference or the exchange of energy and matter between the system and the surrounding. Here, this is an open system. It includes or represents the system at which an energy goes out or come in from the surrounding to the system or from the system to the surrounding. Also, it freely exchanges the matter inside the system, whether it can go out from the system to the surrounding or there is some of the matters goes from the surrounding to the system. So the system which allows the transference of energy and matter from the system to the surrounding and from the surrounding to the system is called the open system. Here there is a closed system. Closed system, like here, this cup of coffee is closed, and what is inside it? Coffee or tea. Okay, tea or coffee cannot go out from the system. But here, if you put your hand around the cup, you feel the heat. So energy goes from the system to the surrounding. In this case, in another case, energy may go from the surrounding to the system. So this system, a closed system, it can transfer or exchange energy from the system to the surrounding or from the surrounding to the system. But in any case, the closed system cannot allow the transference of matter from the system to the surrounding or from the surrounding to the system. So the closed system is the system which allows the transference of energy only from the system to the surrounding or from the surrounding to the system, and it cannot transfer or exchange matter from the system to the surrounding or vice versa. Here it is the isolated system. Isolated system is closed and there is an energy isolator around the container. So the energy inside the container is not changed. It does not go out of the container to the surrounding, and it cannot go from the surrounding to inside the system. So in this case, the system is closed and isolated in the same place. We call this system an isolated system. It cannot exchange matter or energy between the system and the surrounding. So here is an open system, exchange freely matter and energy. Here is a closed system which can transfer only energy from the system to the surrounding or vice versa, and cannot exchange matter from from the system or from the surrounding. And this is an isolated system. It cannot neither exchange matter nor energy between the system and the surrounding. So these are three systems. Open system, freely exchange energy and matter from the system and surrounding. Closed system, can exchange energy only from the surrounding to the system and vice versa, and cannot exchange matter. Isolated system, it is isolated completely. There is no transference of energy or the matter from the system to the surrounding or from the surrounding to the system. So here are three types of systems: the open system, which freely exchange energy and matter; closed system, which only exchange energy from the system and the surrounding; and isolated system, which cannot exchange nor energy or neither energy nor matter from the system and the surrounding. Okay, in the at this moment we finish this session. God willing, we will complete with each other, so stay with us.